Thank you for joining in for today's session on core careers, the first in the series on core careers, which we'll be starting with mechanical engineering and allied areas. We are very happy to have three very esteemed panelists who will cover what careers in this domain look like for students in IIT Delhi. We have today with us Mr. Sibi Thomas from Applied Materials, Mr. Sivakumar Ganeshan from Bajaj Auto, and Mr. Sanjeev Bahera from HCL Technologies. I would now hand over. I welcome to all three of you, sir, and I would now ask Geetika to give a short introduction to each of the panelists and start this discussion. Thank you so much.
Good evening, everyone. My name is Geetika Joshi, and I am a PG coordinator in the Office of Career Services, IIT Delhi. On the behalf of the entire team of Office of Career Services, I take the opportunity to warmly welcome you to this series of workshops. Our objective is to promote healthy interactions between the industrial leaders and our students. Today, we will be focusing on the field of mechanical engineering and will have a discussion on topics like career opportunities in this field, especially during a pandemic, disruptive paradigm shifts happening in the respective industry, the major skill sets the companies are looking for while hiring these students, and also how we, the IITDNs, can help industries in recovering from the pandemic. I will be moderating this session along with Rishabh Goirala, who is also a PG coordinator in OCS. The talk is being conducted in the following format. The part 1, which will be the insights given by our senior panelist, which comprises of Mr. Sivakumar Ganesan, VP R&D Bajaj Auto, Mr. CB Thomas, Head for Selective Products, Business Unit Applied Materials India, and Mr. Sanjeev Behera, Studio Head, Stride Design Studio, HCL Technologies. Part 2 of the webinar will be a Q&A session. So I would like to request all the viewers on YouTube to kindly put their questions in the chat box. We will take all of them together at the end of the session. In the meeting, we also have with us Ms. Anisha Oberoi Madan, Head of Office of Career Services, IIT Delhi. Now let's move on to hearing what our panelists have to say. I would like to start with Mr. Sivakumar Ganesan. He is the VP R&D in Bajaj Auto. He has done mechanical engineering from College of Engineering, Chennai. He joined Bajaj Auto in 1993 as graduate trainee engineer and has been part of design and development of 2-stroke and 4-stroke scooter engines. One is Legend 4S. He has also been a part of indigenous design and development of 125 to 400 cc motorcycle engines for domestic and international brands. I thank him for joining with us today and would like to request him to take over. Over to you, sir.
Hello, am I audible?
Yes, sir.
Thank you. Good evening, friends. My presentation will be basically audio. First of all, thank you for the invitation to this August conclave of mechanical engineers from IIT Delhi. I'll try to discuss on the industrial opportunities and skills for mechanical engineers, especially during the time of a pandemic. I mean, so that he or she can effectively contribute to the well-being of the whole society while he or she establishes his or her professional career. As you know, the need of the hour is to focus on processes and skills that minimizes or eliminates physical presence and interventions in a controlled environment, whether it is a office working or a test laboratory. In general, in most of the situations, mechanical engineering is having more and more collaborations with electrical, electronics, and computer engineering spheres, and is trying to give practical solutions for all our day-to-day challenges. I shall try to focus on the design and its validation processes and a little bit on manufacturing in the complete developmental and supply chain, right from raw material to flowering of a finished product. So let me start with design and its validation. As far as design and its validation processes are concerned, design in most of the spheres are now individualized, standardized, parameterized, and hence computerized. Gone are the days of drawing boards in design offices. An engineer with a strong mechanical engineering basics is able to get into the industrial groove and contribute within a year of his or her training. In Bajaj Auto, we have most of the design softwares in the market, along with the in-house design guidelines and design check sheets. They help an engineer to design and release a component or a subsystem design. Obviously, an exposure to various design softwares will be of great help. And of course, as part of a group, he or she works a part of a design group. The team has review sessions that is done using video telephony, emails, and chat messages. Hence, the skill sets of crisp, specific, and accurate communication and acquaintance with most of the video telephony softwares come in as handy. As always, a basic industry rule is that the skill of observation with an open mind is all important and ever helpful. Observation helps an individual to get into alignment with a new atmosphere quite easily and quickly. Now, coming to the design validation part, at Bajaj Auto, we have both soft and hard validation for all the designs. Soft validations are simulative in nature, and hard validations are done on 1:1 scaled working components, may be manufactured through quick prototyping routes and suitable equivalent material. Basically, it may not match with the final industrialized production route, but a matched thermomechanical properties will be available. So herein, soft validation involves computer-aided simulation and mechanical thermal fluid flow analysis of most of the test conditions required for the final acceptable function, performance, and durability of a subsystem or a product. Of course, the reliance on hard validation or physical testing and data collection, which is highly physical and manual in nature, can be decreased by increasing the reliability of the soft validation. Soft validation, namely the simulative conditions and their analysis results. Herein, the establishment of accurate correlation between soft analysis and the test results of a test condition is very important. Here it starts with the skill of instrumentation and acquaintance with test setups, signal collection, data analysis of test results, awareness about accuracy of the instrumentation used, its calibration of various instruments. These skill sets help a lot in setting up and collecting data from the setup. Here also again a basic knowledge of the electrical and electronic parameters help a lot. The strong and heavy database, both from test setups and in some cases from on-field data, are used alongside of simulative analysis results to predict the performance and life of subsystems more accurately. Hence, knowledge and operating skills on softwares that create setups and boundary conditions for mechanical, thermal, fluid flow conditions and solving of such conditions give a better head start in this field. Maybe such industrial assignments and internship that gives exposure to such environments are to be prescribed and are to be taken during the curriculum. Now let me briefly come to the field of manufacturing. The key word to decrease manual interventions in basic manufacturing and inspection spheres are automation and robotics. This works in all basic areas of manufacturing such as forging, casting, molding, machining, assembly, inspection, all these spheres. The principle of automation and robotics work. Hence, an understanding on the areas of automation and robotics will help and will be handy in improving the productivity and quality of the manufacturing lines of any product. So this is in brief from my side on scenarios and skills. I think I have made a small beginning from which the other panelists can develop maybe. Let me conclude by reminding all of us about the social need of the hour, namely masks, social distancing, use of disinfectants, physical and breathing exercises, healthy heating habits, along with a progressive, positive, and human attitude. Thank you.
Thank you so much for those valuable insights, sir. Now moving on to Mr. C.B. Thomas. He is the head for Selective Products Business Unit at Applied Materials India, where his strong technical background and overall industrial experience are helping drive the division to success. Additionally, he heads the Advanced Product and Technology Development Group for the Semiconductor Products Group. In the current role, Mr. CB is responsible for new product development and sustaining engineering programs for both the divisions. Mr. Thomas has overall 18 years of rich experience in equipment design and manufacturing. He has also been associated with new college graduate hiring, training, and mentoring during the last 5 years. I thank him for joining with us today and would like to request him to take over. Over to you, sir. Sir, you're muted, I think.
Okay. Can you hear me now?
Yes, sir.
All right. Thank you. Can you see my screen, which I'm sharing?
Yes, sir. You can
All
go
right.
on.
Okay. Thank you so much. First of all, thanks IIT Delhi for this opportunity. And I've been associated with IIT Delhi in terms of hiring. I've been there before, and it's a pleasure to be the part of this panel. So before I get started with what are the career prospects and what do we expect with a mechanical engineer when he joins Applied, I would like to go through about Applied Materials a bit because most of you would not know about Applied being in a semiconductor domain, and it's a domain that is not available much in India. So I would like to go through the company a bit. Around 5 minutes, I'll run through the profile, and then I will walk through about the opportunities and what we expect in a mechanical engineer and how would we mold it. So can you see my screen now?
Yes, sir.
Yes. Okay. So Applied is basically a semiconductor equipment manufacturing company. To put it in a in a perspective of a mechanical engineer, it started somewhere in 1967, and it has a revenue of around 15 billion in revenue in as per 2019, and around 22,000 employees worldwide. And most of the 10% of its revenue that it earns has to go back into R&D because for a semiconductor industry, if you want to survive, R&D is the key. And if you look at our customers, most of them are Intel, Samsung, TSMCs of the world, who manufacture your semiconductor chips that is used in your mobile gadgets, your LCD displays, and all that stuff. So we are into the business of semiconductor equipment making. So in core, what do we do? We are basically a leader in materials engineering. So what do we mean by materials engineering is we deposit and we remove materials, we modify materials so that it enables the technology shaping the future. So that is what applied materials does. So what is the role of a mechanical engineer in a materials engineering company is always a question that I face when I talk to a mechanical engineer. So I will walk through it in the coming slides so that you get an overall understanding of that. So if you look at the current era of technology, it started with computing, of mainframe computing in the early 1990s, and then it transformed into internet era where the PCs used to be there, and then the mobile took off, and then now we are in an era of big data and AI. So this growth has been really exponential, in the coming years, and it has remained exponential. So if you look at I've been in this industry for the last 13 to 14 years, especially the semiconductor industry. It used to go in a cycle of it was quite cyclical. So every 3 to 4 years we used to have a downturn where we have to cut cost and all that stuff. But now I think in the last 10 years there has never been a downturn. So even in this kind of pandemic situation, what we are seeing an explosion in semiconductor equipment growth. We're seeing, our machines are, being ordered at a record volumes in the last year, and as well as in this year, and which strongly shows that the end market for semiconductor is really strong. And what are the drivers for this? I will, explain in a bit. So it's all about the data that we generate. If you look at the data that machines use to generate, or machines versus humans, if you compare in last year, the humans were generating around 53%, well, the rest of that was the machines. But if you look at 2018 onwards, machines generating more amount of data, and these what data is generated by all your gadgets. It could be your smart vehicles, your phones, your connected devices. All of that generate a lot of these data. And given the pandemic situation, everybody is working from home, and we all need these connected devices to make your working happen, right? You have to work. So all this has to be enabled by technology, and this is the biggest driver for the semiconductor industry. And the growth for the data is going to go higher and higher in the coming years. And to process these data, right, you need computing, you need high power computing, you need memory, you to store these data, to process this data, you need algorithms which can process very differently. So all these are enabled by semiconductors. And when you look at the semiconductor, if you look at the industry as a whole, right, there is a lot of disruptions happening in the industry, and these are all enabled by the technology. For instance, if you look at retail, Amazon, which used to sell books, have now started into e-commerce, and they are into everything. They sell, they are into e-commerce industry, right? If you look at automotive, that is shaping. If you look at your cars, the amount of semiconductors that goes inside a cars is going, at a rapid pace. And we also have, the healthcare sectors. If you look at pandemic situation now, we need a healthcare system that people can access from remote villages. You have to stay connected. Even I take my doctor's appointment online these days. You don't want to risk going to a healthcare sector, I mean to a hospital, and get get the COVID. So you basically stay at home and get your healthcare done. If you look at education, there has been a transformation in education, right? In terms of everything is going online. My kid is taking classes through online courses and all that. Insurance, banking, all the data has been now into banking. You do mobile transactions, and it's a digital world currently, right? The media, if you look at Netflix, food industry, Zomato's, you can name any industry. All these industries are getting disrupted because of the technology. So going forward, I see, this there wouldn't be a company which doesn't have the technology element being in it. I mean, if the company has to survive, it has to learn very quickly, and it has to adapt to the technology and then change its course. Otherwise, it will get obsoleted very, very quickly. So that is the industry trend as of now. If you look at the large companies like the ExxonMobil, Apple, all these in 2008, these used to be the number one companies. When 2018, it all been replaced by the technology companies, and these companies are not just because of the software or the or because of the products they sell. They are number one. It's because of the data that they handle that they are at number one. If you look at the IoT, your devices, that your sensors, all that, it is collecting a lot of data, has to be driven. It has to be stored, it has to be computed. It's now growing exponentially because the cost of processing this data, the cost of storing this data has become cheaper because of the architecture that we have right now, and also because of the cloud computing that we have. All this has gone economical, and people can easily use this to crunch your data. And there is a saying which goes like, every company will transform itself into a tech company in the future. So all this, what I'm trying to say here is, for the semiconductor equipment industry as a whole, right? It is growing as the market as such. That if you look at the semiconductor revenue as such, it has grown over 2x times from in the last 20 years, from 240 billion to 450 billion in 2019, and it's expected to go to 1 trillion by 2030. The share of semiconductor wafer equipment manufacturing, WFE, what is the wafer equipment, that is close to around $115 billion. That is expected to grow to $115 billion. So right now it is close to around $60 to $65 billion in terms of the overall WFE intensity. So what does Applied do in this space? So Applied is into equipment making. I said the WFE, right? So Applied is the largest player in one of the largest player in the semiconductor equipment world. So what we do is we work with companies like Intel, I said, Samsung, TSMCs, or the foundries, to make we sell them equipment so that they can make these technology which can make it happen in the future. So we sell equipments to these companies, and we also are into this space of global services, which means that for whatever equipments we sell, we also have a services agreement, and which also yields us revenue in that. And we also are into the display space, which is your LCD panel. So we sell equipments. So using our equipments, they make the LCD panels and the OLED panels. So the companies like Samsung, all the big screens that you see, or the TV screens, or your mobile screens that you see, are being are manufactured using one of our tools. So what, if you look at a fundamental level, right? If you look at the at a technology level, if you go down into a let's say a processor of an A10 processor of an iPhone, these are all the devices that needs to be deposited. There are multiple layers of things that needs to be deposited. So these are all materials that are deposited at a high vacuum. Some of them use a very high temperature, very clean environment. Very clean in the sense, even your fingerprint or a human hair can damage, or your dust particle can damage these devices. So whatever devices you design or you make has to enable this chip to happen. This involves very high precision, as well as high technology to do such a um, to, to to build something at this scale of 5 microns, whatever you see here. And if you look at a device level, at a gate level, you are talking in terms of an atomic scales of few nanometers, maybe around 10 nanometers. You're talking in that scale. So to make this device happen, you need to design something. You need to design an equipment which can do a deposition at this scale. So that is what Applied Materials does. And we are also into the displays market, what I said. So Applied is a world leader in display equipment manufacturing. So this is some of the examples of the display equipments that you see, and people standing next to it. So these are all vacuum chambers, inside which you have a big glass, maybe in the size of a 3.5 meter to 3 meter, going inside, where all the deposition and process happens. And at the end of it, your finished product comes out. And if you look at a fab, or look at an Intel fab, or look at some of the foundries, you will have multiple tools like this placed side by side. After the entire process is done, maybe around 1,000 step, or 1,200 step, or 1,000, maybe around 1,000 step, you get your end chip out of it. So the number of processes that happens to make a microchip is quite huge, and it involves multiple divisions to work together. For instance, we will have department of mechanical engineering, electrical engineering, systems engineering, robotics engineering. We'll have the these the you know uh, uh, people from vacuums, gas deliveries. All of that has to come together to make equipment like this. So what does Applied Materials India do? So Applied Materials India is basically in these areas. The main facility is located in Bangalore, and we have also office in Chennai and Mumbai. We have a lab inside IIT Bombay, where some of the R&D happens, and Delhi we have our government relations office. So just quickly going in, so that understand what we do in terms of product development. We have an exploration lab in Mumbai, what I told right now, and we also have a hardware validation lab, which is in Bangalore, and we also have a reliability setup in Bangalore. Um, so if you look at the roles for mechanical engineers in applied materials, it's basically a hardware design where you'll have to design chambers. Whatever you saw in that picture, right? You have this whole chunk of aluminum blocks which needs to be designed, machined to arrive at a final product. And this is not, this involves a lot of simulation to be done, a lot of um, back and forth calculations, and work with the expert teams to arrive at that design. So so you have chamber engineering, frames, automation, tooling, testing. So these are different areas where a mechanical engineer can play a role. We also, all these product has to be validated and has to be robust and reliable. So we have a reliability group in applied which check these parts for failures, and the hired engineer will also be a part of this. If he gets selected, he can also be part of one of this division. He can be a simulation engineer where all these devices has to have a, let's say, if you look at an heaters or an e-chucks, they have to be a very high precision in terms of temperature uniformity. It has to be maybe at 1 degree uniformity or maybe less than that. So it involves a lot of these design and simulation iteration back and forth to arrive at the final design. And some of the NCGs or new college graduates of hired also has gone into data science and machine learning, where we try to take the data out of our devices to make it better. And there is also a group for that, so you can also be part of that. And also there is a big group for manufacturing, which is we call it new product manufacturing engineers, who work together with the manufacturing unit in the US to make sure the design, whatever we do, is assembled together properly. It's has, if there is any issues in terms of assembly, that is corrected. They interact with the design team to make sure that happens. And if you look at manufacturing, it is global. It happens all around the globe. Some of the parts, like the ceramic parts, comes from Japan. Some of them come, some of the machine parts come from China or Singapore or US. So all of this, the NPME has to make sure all this goes into the fab, into the shop floor where these things get assembled, and you meet the timeline that is committed to. So, and also there is a group for DFX and value engineering, where the cost, or the design for assembly, design for serviceability, all that are looked into. So when we come for interview into any institute, I mean, we go to all top tier institutes to hire fresh college graduates, and the skills we look are basically fundamentals, fundamentals of engineering, and how do you apply engineering in your day-to-day life. um, let's say if you see something, if you see a scooter, how does a scooter work, or how does a pressure cooker work, how does a sewing machine work, all these, if you are curious enough, you would go in deep and then find out, using your fundamentals that you've learned in your basic engineering, and then try to understand that a bit more. So that's exactly what we probe in the interviews when we do. And we also look for manufacturing knowledge. We don't expect the engineer to know our manufacturing processes, but we expect them to know a basic fundamentals so that we can mold them. So when a new engineer comes into applied, he generally goes into an 18 weeks training program where we have we walk them through different we processes that we have, different fundamentals that especially for the vacuum related, we train them. And then we also give them a couple of projects so that they work with different business units, so that they understand how different business units work and what are the different projects they handle. So they get trained in that period of time. So we don't look at vacuum technology and all that, but we look primarily at your fundamentals. So and we also look at the behavioral side of things. For instance, how do you solve a problem? What are you are you self driven? um, do you have integrity? So this should go in line with our core values. We also probe that using a behavioral event interview, and then we try to assess a candidate, and then we go in for hiring the candidate. So generally, if you look at what has changed in the pandemic, the style how we work has changed. If you look at the new college hires that we hired in the last year, we used to have face-to-face discussions in the previous year, and we used to have a very good mentorship program and all, but that has gone online this year. And for a new college graduate, it's always a challenge because they don't see things in real, and they sometimes we have people working from their home also, so we have to spend a lot of effort to make sure the candidate is up to speed, he is able to work on the projects in a very shorter time span, and is productive. So we do it, we use the previous years before pandemic, it used to be a different process, and from this year we changed the process so that we can be a little more effective given the constraints that we have right now. So this is pretty much what I had to cover in this given time slot. So I'll be happy to take questions in the end, and would like to hear from the panel also. Thank you so much.
Thank you so much, sir, for those valuable insights. I would like to remind all the viewers to put their questions on the chat box. We'll take them together after some time. Now moving on to Mr. Sanjeev Behra. Mr. Sanjeev currently heads a design studio called Stride, which is a part of the engineering and R&D services business of HCL Technologies. It is a domain agnostic multidisciplinary design studio. In the 15 years since inception, the studio has established itself as a leading design studio, working with Fortune 500 companies in medical, consumer, and industrial sectors. As the head of the design studio, Mr. Sanjeev manages the responsibility of all project delivery at the studio, mentors a team of multidisciplinary designers, interfaces with clients and leadership teams, provides thought, leadership, and creative direction to projects. He has 14 plus years of work experience spread across multiple domains such as medical devices, consumer appliances, smart home devices, etc. I thank him for joining with us today and would like to request him to take over. Over to you, sir.
Thank you, Gitika. Hi, everyone. This is Sanjeev here, and it is an honor to be part of this panel and an honor to be speaking to the faculty and students of IIT Delhi. Yeah, I hope my screen is visible.
Yes, sir.
Okay. Just give me a second. Yes, I hope the screen is visible now.
Yes, sir.
My name is Sanjeev, and I represent HCL Technologies here. Before I really, get started on the topics for the discussion, just a quick introduction about our company. This is a snapshot of some of the key parameters of the organization. So HCL Technologies is a large IT services company. As in India, we are number 3 in terms of the revenue and the size. We are currently just sort of a $10 billion revenue company, which is spread across multiple geographies. We have presence across 46 different countries. With about 150,000 employees, or we call them as ideapreneurs, are the core base of this organization. Employees are the ones who build the value for HCL Technologies and has been at the forefront of the design, development, and activities of the company. We drive innovation, we drive and design and development activities for our customers across different verticals. We are having strong business presence across verticals such as financial services, manufacturing, technology services, life science, healthcare, so on and so forth. From a service point of view, HCL Technologies is spread into three main business divisions: IT and business services, engineering and R&D services, products and platforms. The engineering and R&D services is about 17% of the total revenue. That is close to $2 billion revenue of the $10 billion revenue that HCL has currently. I represent the engineering and R&D services today, and considering that we are currently talking to the mechanical engineering division students. This team has a strong position in the mechanical engineering domain. Large part of the engineering and R&D services business workforce comes from the mechanical engineering services background. So, and I manage a design team within the engineering and R&D services, which works on a new product development in the areas of new technologies and so on and so forth. So this is a quick, introduction of the company of HCL Technologies. So we are in a time right now where things are changing quickly, and the topic for the discussion today is the changing paradigm of the businesses at this point of time. We have adopted change the change that has come across due to the COVID-19. But as we are currently in the 8th or 9th month of the COVID impact, we see COVID as a trigger of change rather than a cause of a shift. So initially, a lot of change happened, which was due to COVID. It was caused because of the impact of COVID. But as we see today, after almost 8 and 9 months of the impact, we see a lot of changes are happening in the industry, which is not because of the COVID. These changes were happening even before the COVID happened. A lot of technology adoption, change of technologies, and adoption of new technologies across industries were happening even before COVID started. However, what we see today is a trend where COVID impact has triggered a massive change in these behaviors, change of these technology adoption, and we see the technology is embracing these, industry is embracing these technologies more and more and more frequently. Traditional manufacturing is giving way to smart factories. A lot of our customers have started adopting smart manufacturing processes, smart manufacturing technologies, and this change has accelerated in the last few months. From a mindset of extending legacy product life cycle to getting into new products, new technologies. This is a trend which we are seeing across domains, whether it is in medical devices or consumer appliances or industrial. we see this trend across different customers, across different industries. And this is not specific to one particular geography. We are seeing this across in all major economies, in all major geographies, where this change of companies in investing heavily in new products and, or new technologies has accelerated. There is increased focus on technology adoption, IoT, AI and ML, automation, extended reality. These are some of the technologies which are being adopted and being embraced by the industries more frequently today than it was earlier. But at the same time, we all know these are not new technologies. It just that the adoption cycle has accelerated, and that gives us an opportunity to upskill ourselves, work on some of these areas, and meet the demands of the industry quickly. Now, what does this mean from a career opportunity point of view? What we are seeing today is the opportunities in R&D projects in multiple different domains or verticals, such as healthcare and medical devices, consumer electronics, kitchen appliances, home appliances, etc. Industrial applications remains very strong. There are a lot of opportunities in these domains, in the new product development, in new technologies, which we see as a very, very positive trend. Even some industries such as auto and aerospace industry, which initially had a very negative impact due to COVID, are also recovering quickly, and we see an upward tick in and the opportunities coming across from in the industries which were impacted heavily because of the COVID impact. So all in all, we see a positive trend in opportunities coming across from different businesses. Skill sets are in high demand in engineering services, particularly in the industry where we come from, the engineering and R&D services division. A lot of focus on new product development, on adoption of new technologies in manufacturing, in product design and development. My team works on industrial design. This is a skill which is very niche area, and we see a lot of demand in industrial design. Customer centricity has become a core part of new product design and development, and hence design, user experience, industrial design has become a very, very important aspect of the new product development activities. Apart from that, engineering skills in IoT skills and other mechanical engineering skills are also in high demand. New product design opportunities are on the rise, especially in the areas of targeting to the new changing demands of consumers. The consumption pattern of consumers have changed. The demands of the industry is changing, and there is a need to work on new products, new projects to meet this particular demand. And hence, there is an increased focus on IoT skills, augmented reality skills to meet this demand which has come due to the COVID-19 impact. It obviously has triggered new ways of working. There has been a lot of emphasis on core skills, fundamental skills, basics of mechanical engineering, basics of engineering, fundamental skills of new product development and design. Communication skills has become a very, very key aspect of the designer's work and activities. Today, apart from the core engineering skills, communication skills are very, very important due to the distributed nature of work. We all continue to work from home. That means more focus on communicating with different stakeholders, different team members, clients, and having good communication skills is an asset which cannot be emphasized enough. Um, the change of focus from the ability to work as a team to work in a team has also become a core element of the new workforce. Earlier, people used to be part of a team, so work in a team was being a good team player, being a good team member was important. So being part of a team or work in a team was important in the pre-COVID era. But as we work or develop products in this new time, in this new situation, working as a team is more important today. Everybody is equal. Everybody is important. The boundaries of a senior designer, senior engineer, junior engineers, or a junior designer has all gone. Today, everybody is equal stakeholder in the team, and working as a team is very, very important today. Hence, there is a lot of emphasis on remote collaboration, adoption of new technologies across different skill sets. That has been the core of the changing nature of work today. Now, working at HCL Technologies or the Engineering R&D Services division of HCL Technologies, the core elements that you get to experience are being part of a multidisciplinary team. So we pride ourselves in the diversity, we pride ourselves in terms of the skill sets, diversity that we possess. Being part of this team, you get the exposure to work across this diversity in terms of skill sets, diversity in terms of cultures, distributed teams. You might get to work on a project where your team members are not only from different skill sets, but also there are people from India, people from Europe, people from China, Japan, US, and team members working in different time zones in different geographic locations. This is a challenge, but at the same time is very, very fun to work in a team as multidisciplinary as this one. You get a chance to work across the global clientele, get a chance to work on products which are global in nature. So global exposure is a key or a added advantage being part of this team. Apart from that, world-class infrastructure. Today, this infrastructure has helped us sustain the impact of COVID-19 as we work from home. Even this infrastructure has enabled us to work from home seamlessly, even if we are not working from the office premises. So when we talk about infrastructure, it goes beyond just the physical infrastructure, but also the digital infrastructure, the IT backbone that the organization has created. This has enabled us to work from anywhere without impacting the quality of deliverables, quality of work, and the policies of the organization has gone a long way in enabling us to do that. As an organization, we have always focused on employee first, and that mindset, policy of the organization to focus on employees has helped us sustain the impact of this and continue to grow even in the situation where a lot of companies in the world has seen their businesses getting negatively impacted because of the COVID impact. But for us, it has been a continued upward journey in spite of that. So that's something which you get as part of this team. So when we hire new resources or new designers, new engineers in the team, we continue to look for core skills, strong fundamentals, strong core skills in mechanical engineering, in industrial design, in AI and ML, in IoT technologies, etc. So core fundamental skills are important, and we do follow a tiered approach in terms of evaluation of skills, where we do interviews, we do design tests, and multiple different interactions with key stakeholders as part of the evaluation of core skills. So the focus definitely is on the core fundamental skills. But in addition to that, there are a lot of other soft skills which are important and has become very, very important in this new changed work scenario as well. So we look for ability to work in collaboration with other people, ability to communicate with others, the resourcefulness of the employee, the ability to listen to others, ability to build coalitions, and the diversity and transparency of the workforce is also a key element for us to look at while building a team and augmenting a team. So these are some of the areas which we focus on, we look for as we build a team or hire new resources, new designers, new engineers in the team. So yeah, so I think that's all pretty much from my side. And thanks a lot for the opportunity to speak and present our viewpoints and thoughts. Thanks. Back to you, Gitika, and the panels.
Thank you so much, sir. I would like to request Rishabh to take over for the Q&A session. Over to you, Rishabh.
Thank you, Geetika. Good evening, everyone. So we now move on to Q&A session. So the first question that we have is how industrial designers can add value and what all skills they have to develop. So anybody would like to answer this question?
Maybe since this is industrial design, let
Yes,
me
sir.
start. I also request other panel members to add in and answer also. But from an industrial design point of view, we look for core fundamental design skills in industrial design, the ability to understand the users of the product, and the ability to empathize with the end users, understand their challenges, ability to focus on design research is a core area for us while recruiting industrial designers. In addition to that, the fundamental skills of industrial design of human factors design, sketching, CAD modeling skills, the attention to detail while sculpting or while modeling a product is a very important skill for us when we look for young designers to be part of the team.
Thank you, sir. So next question is how active are industries in collecting data from machines and vehicles for their health monitoring remotely? So Mr. Sivakumar.
Rishabh, can you just repeat the question?
Yes, sir. So how active are industries in collecting data from machines and vehicles for their health monitoring remotely?
Oh.
So did you get my question?
Yes, I think I've got the question, but don't have a specific answer for that.
Okay.
Sorry.
Okay, sir.
Maybe I'm associated with a different field.
Okay. So no worries, sir.
Yeah.
So the next question the next question
very
we
quick.
have is
So if so, I would like to pitch in some of the perspective from applied materials. So this is not specific to vehicles, but in terms of we collect a lot of data from our machines, especially if you look at the consumable aspect. Each of the part would cost you thousands of dollars, and if you need to replace these parts out of a chamber or a machine, if you want to take them out, that would, for us, it's the maintenance time or the takt time that is needed to remove it is quite huge. I mean, the customer will not be willing to give you a tool downtime. So we have a lot of these sensors that are kept within the chamber, so that if there is a consumable which is getting consumed over a period of time, we get track that, and then so that we can exactly predict by when we can replace those parts. So those kind of things are now part of the with the tool design, I mean the system design right now. And there is a lot of emphasis also from the customers to have these in place, so that we can optimize the downtime of the tool.
Okay. Thank you, sir. Thanks for the answer. Moving on to the next question. So it is how a thermal engineer can update his skill sets to be still relevant in the field. So can anybody answer this question?
Can I take that question?
Sure, sir.
So if you look at if you look at our uh, tools that we use at Applied, most of them have thermal is a big ingredient in it. As I told during the discussion, that even a 1 degree change in a temperature can affect the uniformity in a chip. So we want to make sure that 300 millimeter of wafer that you have should have at most uniformity as possible in terms of temperature, and in terms of the the specific controls that we have, feedback loop controls that we have. And if you let's say if you have heaters built in, you can't have a coil type heater. What different types of um, designs can you bring in, so that you can have a distributed heat on your substrate? So you have your gas flow through to the top, and the heat removal from these devices or a pedestal or a substrate could be different at different areas. And the role of a thermal engineer is quite significant um, in semiconductors. For instance, we that's why I said during the design we go back and forth in terms of iteration, so that we achieve this uniformity. We test it out in the field, and then especially when all the three modes of heat transfer: conduction, convection, radiation, all of that is significant in a vacuum chamber, because at a low pressures the radiation will be quite predominant for heat transfer modes. And so how does that couple with the structural is also very important. How does the thermal and the structural get coupled and affect your overall system is something that also has to be studied. So I think thermal is a very big play in our industry, at least.
If any of the
Probably
other
I
panelists
can
would
add
like
a
to add,
bit.
sure.
Let me answer it in two phases. One uh, related to an IC engine. So, needless to say, that importance of thermal engineering in energy generation and dissipation, and parameters that affect the affects and lead to a efficient design or a weight optimized design for an engine is obvious. So all the heat transfer modes and heat transfer coefficients and heat transfer atmosphere are used for our analysis for the overall design of an engine. And this, along with the um, structural rigidity of the various components and subsystems, especially at higher temperatures, where the properties and the physical properties of this material vary a bit, and you need to adequately compensate it considering those running conditions. This is one part which is related to IC engines. So other than this, even if the prime mover is not an IC engine, the thermal management of any say vehicle is very important. How the heat as um, as faced by the rider customer or a pillion in case of two-wheeler, and how the thermally how the air is conditioned in a four-wheeler. So I am not very much into that subject, but for the two-wheeler I am very clear. Thermal engineering plays a very important part for the rider comfort, rider and pillion comfort, as well as the thermal stability of other components in the vicinity of the dissipated thermal energy. So these are areas which are very important for the durability and comfort of durability of the machine and comfort of the rider. So thermal engineering surely plays an important role in automotive sector. Thank you.
Thank you, sir, for such a great answer. Moving on to next question. It is, what kind of challenges a fresh engineer is going to face in R&D companies, and how can he face them? Like, how can he overcome these challenges?
So let me take that question. So when we hire new college graduates, and I've been associated with them for the last 5 to 6 years in mentoring them and training, the one primary um, you know thing that they expect is people to come and then teach them, or let them walk through the process and all that. What we expect is the other side. We would want the new college graduates to go and then do a lot of networking. All lot of these things, a lot of the new concepts or new ideas are already existing in different places of the company. Some company have it well documented, some do not. So unless you reach out and build a network, that that is a skill that you need to have, so that not just sit in your table and then try to solve the problem by yourself, but how do you reach out to people, how do you understand if the design is already being done, uh, and also go a little bit deeper into the problem statement. For instance, if a part is failing and you've been asked to find why a part fails, don't just stick into that particular component. Look outside that component also. What other components could lead to the failure of this particular component? What is the composition of this particular part which is failing it? What conditions make it to fail? What is at a structural level, go into that level, materials level. Try to troubleshoot that problem from a different perspective. Don't just focus on your own subject. I've seen people from thermal engineering side coming and then trying to solve a problem just from the thermal side alone. A structural guy who's focused on structure will try to solve the problem from a structural angle, rather than bring in a holistic picture. Try to analyze a system on how it has been used in the actual environment. Try to picturize that and then try to solve the problem. That is number one. And second is build a network of people. When you join a new organization, try to build that. Try to reach out to people, your seniors, and then especially during this COVID, when you need a lot of help of people to to tell you where these tools are lying, how do I access the design part of it, how do I quickly get it done. You would need to build that skills. I think one of the speaker from HCL also pointed out communication at this juncture is becoming very critical. So networking is a key area that you should also focus on.
Okay, thank you, sir. So moving on to next question. So it is, how industries are utilizing the knowledge of ML and AI and combining it with the mechanical engineering to build an excellent product. So if anybody would like to answer this question.
Yeah, I can take that. So if you look at I told you, right, when MI is, what do you mean by MI? It's like the machines are are crunching the data that you generate and giving you an information which is really significant enough for you to make a decision. So that is what you know. If you look at the mechanical engineering aspect of design, right? If there is a a failure in a heater element, let's say one of my heater which cost maybe around $20,000 to $30,000, if that particular heat element is failing, the what we look for, earlier we what we look for is to take the part out, run a reliability test, find at what modes exactly you have run in the current fab or current setup. What was it run it, rerun it again the same conditions, and then try to predict the failure. But now we are looking for signatures for failure. You're building all of these sensors within the system so that you pick up the signals before it fails. It could be a noise signal, could be could be the data that that particular heater generated, could be the current signals that had, or could be the you pick out all these data, crunch those data in the server, and then come back with the with the failure modes, and then tell the you can predict the failure and you can replace those parts before the part even fails, and that way you can avoid the downtime and all that. So I think it is in terms of IoT, right? How you can plug it and how you can generate the data and how you can process and give you a valuable information is coming into play right now. And also for this helps the spares division also. I told you, right, the global spares team, they can be prepared so that they don't have to go and get a part and make it reach to a customer fab only after the part fails. They can get prepared, line that up for the maintenance so that they can be prepared for it, so that you can avoid um, the delay in bringing the tool up.
Yeah, I think I can add to what Mr. Thomas also said. AI and ML has become a very important part of engineering and R&D services. And for a mechanical engineer, some of these skills and familiarity to these skills has become a core part of the product development process. So some examples that we have worked on projects recently, which can be used here is we worked on a with a customer in the consumer electronics domain. They manufacture refrigerators, washing machines, so on and so forth. We have designed algorithms within the appliances themselves, where if a certain part is going to fail, it can predict that before the part actually fails. And a lot of that is similar to what Mr. Thomas also said. We are looking at signatures. We are looking at the noise that some of the parts make to predict how the particular component or part is doing when it is likely to fail. And with that, we can generate data which helps the consumers to understand the pattern and do a maintenance before it becomes too late, and which can affect the performance of the device. Similarly, in the with another customer where we work with them in the areas of printers. A lot of technologies in the MI ML technologies help us in giving data to the consumers with respect to how the print quality is coming in, what can be done to improve print quality. Is it a cartridge related issue, or is it a roller related issue, or something else? So some of these technologies today are helping us improve the quality of output and predicting what could be done to improve the quality. We work with medical device customers where we use machine learning to build a better picture of a 3D model of the bones for an orthopedic surgeon to take decisions with respect to what decisions they can take or which approach they should follow for a specific patient. And this bone model we are able to build from the data of X-ray data that we have. And why machine learning is so important is using X-ray imagery of a particular patient. It is very difficult to build an accurate image of the bone from only one patient's database. But as we collect more and more data, now that we have hundreds and thousands of patients' data available, we are building a model which the hospital can use to be able to accurately visualize in 3D how the patient's bone structure is, where there are fractures, and what challenges could be anticipated before the surgeon actually starts, the procedure or the operation. So today, these technologies of machine learning, AI is almost everywhere. You from consumer appliances to medical devices, this has become part and parcel of every device design and product design process. Hence, it is important that the students are familiar with these technologies and are learning the skills as part of the core skill itself.
Thank you, sir. Thanks for the answer. So moving on to the next question. Next question is, with the upcoming electrification, the disruption in the automobile field, how is a mechanical engineer's role affected by this?
Probably I can take it.
Yes, sir.
See, basically, while we are also working in electrical technologies, the vehicle, end of the day, is a mechanical part. So other than the prime mover, there are other systems on the vehicle. Simply put, the chassis of a vehicle, the suspension of a vehicle, the brakes of a vehicle, the swing arm of a vehicle, front fork of a vehicle. So all these parts are going to be there even if the prime mover is substituted. So mechanical engineer is and will be associated with this automotive industry in various other areas other than the say the powertrain part. And even in powertrain, the probably the power pack is replaced. The transmission part will always remain. See, how to get the power from the prime mover to the wheels is always a mechanical engineer's skill.
So let me bring in a different perspective to this question. So generally, the idea is the mechanical. When we get into a field, right, we think mechanical engineering means design of a machine part, or could be in manufacturing, or it could be drawing, simulation. It doesn't end there actually. So over a period of time, the mechanical engineer, what is expected out of him is to understand the system as a whole. So he would eventually, in a period of time, move into a systems engineer. He understands the complete system. It could be electrical, could be mechanical, could be RF, could be magnetism, could be, all of that. He would thermal, all of the vibrations, all these areas, not just not just specific to mechanical engineering. All of that as a system level, he should be able to understand. So if you take I'm not going into the automotive area because I'm not too familiar in that space. But generally thinking, you start your role as a mechanical engineer in any company, and then try to learn other domains as quickly as possible. Whatever your system interacts with, you should pick that skill so that you can provide solutions as a whole. Because when a system fails, it's not just the mechanical engineering part that fails. It is just a module that could be integrated module will fail. So you will have to work closely with them to troubleshoot. So that perspective we need to change.
Thank you, sir. Thanks for the answer. So moving on to next question. It is, in terms of physical prototyping for designers, how are you working on the projects remotely in COVID era?
Can you repeat?
In terms of physical prototyping for designers, how are you working on the projects remotely?
Oh, so if I can take that question. So for us, right, for the last few months, we tried our best, to remote working, and tried, to send one, few people. We have very strict norms at office, on following COVID protocols. Um, but still, we have to meet the timelines, right? So we make sure, we when you build the prototype, even the supplier sometimes, cannot provide you on time because their workers do not come to work and all this. We had all these issues in the last few months, but now I think we have settled these things to a certain extent. We have devised protocols by which a person comes in a certain timing, um, and only people who are required to work on that particular module will be present, and with all safety protocols we get that project executed. So we space out the timings so that whoever needs to work on can only come during that particular time, and also the sufficient spaces, I mean, in terms of gaps, in terms of spacings are all given between different modules so that you can work independently and integrate it, and then you can uh, combine it together. So it's working for now, but I hope the situation doesn't go like this for the future also. We would want people to put, um, this condition also should change, is what I hope for.
If I can add, I mean, obviously the productivity of prototyping has taken a hit. Um, I can only suggest that we manage it with uh, the subsequent activity, because usually after prototyping it goes for testing. So we align the prototyping in such a way that its testing is planned and scheduled immediately, so that the waiting period for a prototype is reduced. I mean, it is basically on planning.
Just to add slightly different perspective here, and some of the other technologies which are helping us to do these prototypes evaluations better, is today a lot of our customers are actually using augmented reality and virtual reality for some of the design decisions which traditionally were taken with a physical prototype alone. Using mixed reality technologies, you can actually evaluate the fit and finish of the design, the quality of prototype to a very large extent, where some of that technology today is helping to uh, bypass the need for a physical prototype, which was traditionally being used along the way of the product development cycle earlier. So just a slightly different perspective here. Physical prototypes are important, has always been, and even now also it is important. A lot of those and decision making and processes are something which we are also working on to make it easier to make those prototypes quickly. We are trying to set up our own 3D printing facilities to be able to make those prototypes quickly. So all those are also happening, but at the same time, like mixed reality is also helping us to evaluate a design without a physical prototype being available.
Thank you, sir. So moving on to the last question, since we are running out of time. So this is the last question of today. So what are the advancement in the rapid prototyping that is coming in India?
I think 3D prototyping or a 3D printing as an industry, as a technology, is evolving very fast. Metal prototyping, metal printing, and other additive manufacturing technologies are becoming commonplace. many of our customers today are trying to embrace 3D printing as the core technology of choice for their final product manufacturing. So for many years now, for the last 10-15 years, 3D printing has been a technology for your engineering design and development cycle. Don't use 3D printing for your final product. That's typically how 3D printing has been for last 15-20 years. But today it's not the situation anymore. 3D printing is is advanced today, where many of the products are being printed instead of going with traditional manufacturing techniques. In fact, we are working with many of our customers to build their technologies, their manufacturing setups in a way that 3D printing could be used to manufacture products. So this is an important development in technology, and is moving very fast. And even the regulatory requirements are also evolving, which is allowing us to 3D print products rather than go with traditional manufacturing of these products. So it's also becoming more and more acceptable across industries. So this is an important piece of technology to look out for in the next coming few years.
I think to bring in some perspective from semiconductor industry, I think what we the plastic, or the plastic 3D printing has been very famous and very popular, and people use it for form fit function or even the testing. Metal 3D printing is a space that we've been always been interested in, because that gives us the ability to combine parts together, and it gives us a competitive advantage of introducing new features, which otherwise is not possible using the regular manufacturing processes. So but some of the challenges we still face in that metal 3D printing is the density factor, that you're not able to achieve 100% dense, and there's sometimes the surface finishes that is a problem. The in terms of high volume, if you want to really kick in 3D printing, you need the printers which can make these parts at a highly productive, right? I mean, at a high throughput. So that is not until these things really take pace, we would still be restricted to using it as a prototype. And if there has been a lot of work going into this area, we also um, know, and we have adjacent markets in the space where we're trying to look into also, as a 3D printing is one of the area that we look in, and the multiple companies are investing in the space so that these issues, whatever I said in terms of throughput, in terms of finishes, densities, all of that, if we can take care, I think this is one area that can disrupt manufacturing as a whole.
We here in Bajaj Auto use metal sintering for prototyping, both steel and aluminum parts. We have used only in prototyping, not for mass manufacturing. And as Sibi was mentioning, we are also facing some challenges to match the thermomechanical properties with a final manufacturing method. Typically, if you can think of heat treatment process, how to get the same property with a metal sintered or heat treatment followed, metal sintered followed by a heat treatment process. Those areas we are also working. At the same time, we are using these metal sintered parts for our manufacturing, and we are able to take judgments of the performance of the components.
Thank you, sir. Now I would like to request Anisha ma'am on the behalf of OCS to deliver a vote of thanks.
Thank you to all the panelists for giving so much of their time and these valuable insights to students about how the mechanical engineering and allied domains would look like once they enter industry. and maybe that could give them some pointers on how to prepare for the final selection interviews and do well in those interviews. We look forward to welcoming all of you now for the interviews as well. Thank you, Mr. Ganeshan, Mr. Thomas, and Mr. Bahera. Thank you so much. And, I'll hand it over to Geetika now, and to the team, the entire team of OCS who put up this entire panel as well, for all their hard work, Rishabh, Geetika, and the rest of the team. Thank you so much to everybody. Geetika, why don't you take over now? Thank you, everyone.
Thank you, ma'am. Lastly, on the behalf of OCS IIT Delhi, I thank each and every panelist and all the viewers who were watching us today. I sincerely hope all the viewers must have benefited a lot from such an amazing session. We hope to see you again next time for more such amazing webinars. Until then, stay healthy and stay safe. Thank you.
Thank you so much.
Thank you. Thank you.
Thank you. Thank you so much.